So my sister asked me this question over the holidays, which I thought was a good one. Basically, why do physicists come up with wild theories like quantum mechanics or special relativity? Like, what's their purpose? And I think the problem is that some people who aren't necessarily in science maybe see these as just a bunch of ideas that scientists who claim to be smart come up with because they sound intellectually edgy or mind bending or whatever. But the truth is that all these ideas come from a need to explain something we observe that we currently can't. I mean, in the 1500s, people thought disease came from quote unquote bad air in certain places, for example, until scientists started noticing that things like practicing good hygiene cuts disease rates. So, scientists came along and proposed germ theory, which explains disease really well. And you can imagine trying to convince a bunch of people at the time that tiny invisible animals are what causes you to get sick in certain scenarios. It would have sounded absolutely crazy at the time. But a good theory like germ theory isn't just good at explaining things, it also has good, what we call predictive power. So we put them to the test on how well they do at predicting outcomes to experiments. Germ theory predicted disinfecting medical equipment would lead to less infections, for example, since doctors back then used to do things like autopsies and childbirth with the same dirty instruments. And we now know that sterilization works. And it's exactly the same case in physics. In Einstein's case, for example, the big observation at the time was that the speed of light is the same for all observers, for everybody. No matter how fast you're moving as an observer, the speed of light is always the same. And before special relativity, we didn't have a way to explain this. It really goes against kind of what we're used to in everyday life, but special relativity explains it really well. We've also put special relativity to the test in many scenarios, and it has made very accurate predictions. Now, if we encounter an observation that a theory can't explain well, we go back to the drawing board, we make adjustments, we start again, whatever is needed, because that's the scientific method. It's based on evidence, and that's what makes it so powerful.